We are in the third part of lesson 61C. Data consists of a bunch of numbers. I mean, we kind of get that. And for example, we've got a set of scores here from a test that a teacher gave. And there's 32 students here. And these are their 32 scores. And we have grades anywhere in the 90s, in the 80s, in the 70s, 60s, and we even have some 50s. Maybe do we have? Yes, we have 155 here. So we have a wide range of scores. So a good first step to analyzing is to put them in order from highest to lowest or lowest to highest, so we can identify the range of the numbers. It's going to help us identify the mean and the median and the mode and all of those numbers if we organize them. And a good first thing to do, or first step, is to put them in what's called a stem and leaf plot. And the stem is right here. A stem is basically the dividing line between the tens place and the ones place. We're going to put the tens place here. We'll have 90s, we'll have 80s, we'll have 70s, we'll have 60s, and we'll have some 50s. And this is the tens place. And then over here we'll have the ones place. And then the first thing we'll do is we'll go through and look for all the 90s. So I have a 0, I have a 6, I have a 5, I have a 2, I have a 4. Let's see, I have another 2, I have another 6, and I have another 6. And those are all my 90s. Right? And I'll go through it and I'll do that process for the 80s and the 70s and the 60s and the 50s. So let me do that and then I'll come back. So here is my stem and leaf plot for this set of scores that we have. All right, and so one of the things you want to do whenever you set this up is to double check your quantity. 1, 2, 3, 4, 5, 6, 7, 8. That's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So I have all of the numbers recorded. Now you can see they are not in any kind of order. This is just the order that they were listed. Like if I had a 90, I wrote down a 0. If I had a 78, I wrote down an 8 next to the 7. If I had, the next number was 96, so I put a 6 down. The next number was 80, so I wrote a 0 next to the 8. And that's what I did. Now comes the second step to a stem and leaf plot, and that is writing the numbers in numerical order. So I would take my little dude, my little circle gadget thing here, and I would just move these little numbers around. Now normally you would just swap them out, erase them and rewrite them in the proper order. All right, hopefully you would make some notes that would help you do that, but having a cool little gadget like this helps a lot. So that's what you do. You want to reorganize your numbers in numeric order from left to right. So let me do that. So now I have all of my numbers organized from highest, which is 96, all the way down to the lowest, which is 55. And they are in numeric order. Now, doing it like this, it's really going to help me see things like mode really quickly. So right here, I can automatically see that my mode is going to be 83, because 83, this 3 is repeated in the 80s row 4 times, and there's not another number. 6 is the next highest, and it's only repeated 3 times in the 90s. So my mode is going to be 83. And that was really easy to determine. I didn't have to count and make tally marks or anything like that. So organizing your data is very important when it comes to determining your data analysis. So we can use this plot to record the numbers from the least to the greatest really easy, and it also helps us to find our range really easy, because now all I need to do is take the highest number, which is 96. So the range is going to be the highest number, 96, minus the lowest number, which is 55. And I got that from taking the rightmost number in the top row and the rightmost number in the, or the earliest number in the bottom row. And that would be how you find range. And 96 minus 55, that's going to give me a range of 41. So that's pretty cool. Now, to find my median, all I have to do is find my middle two numbers. And the way you do that is, we know we have 32 numbers. Well, that's an even number. So I need to find the middle two numbers. So all I need is number 16 and number 17. So I just count. And I know this is 1, 2, 3, 4, 5, 6, 7, 8. So that means this is number 16. All right, 9, 10. Actually, no, I have to count backwards. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 and 17, right? These are the middle two numbers, 80 and 83. So 80 plus 83, and then divide that by 2. And that is going to be 163 divided by 2. That's going to be 81.5. Is going to be that number. Yes. So that is my median. That's my middle number. So now look at my mode and look at my median. See how closely related they are. So now what we need to do is look at our mean. We need to find our mean. And our mean, we know, is the sum divided by the number. And the number we already know is 32. But now we need to find the sum. So the easy way to find the sum is to figure out how many numbers you have for each set of tens. And it'll be 10 times 9. So 10 times 9, 10 times 8, 10 times 7, 10 times 6, 10 times 5. And then you put the quantity here. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 times that. This is 10 times that. That's the number. 1, 2, 3, 4, 5, 6 times that. 1, 2, 3, 4, 5, 6, 7. And then this is just 1. So then we find the calculation for each one of those. Let me see if I can pull up my calculator for that. All right, so we are going to, let's see, 8 times 10 times 9. So we have 720 here. And then we have 10 times 10 is 100 times 8. That's going to be 800. 6 times 10, that's 60 times 7, that's 420. 7 times 10, that's 70 times 6, that's still 420. And 1 times 10 times 5, that's 50. And then we add all of those up. And we get, that's 9. Nope, that's 11. Carry 1. That's 16. 24. So 2,410 from the tens column, right? Now we just need to add in the ones. And that's really just very straightforward. We have these values in numerical order for a reason. So we have 2 2s. So that's, or actually let's do the ones first. So we have 2 1s. So that's 2 plus, this is 4. Plus we have 1, 2, 3, 4, 5, 6 3s. 6 times 3, that's 18. Plus we have 1 4. Plus we have 1, 2, 3, 4 5s. That's 20. Plus 1, 2, 3, 4 6s. That's 24. Plus 1, 2 7s. That's 14. Plus 1, 2, 3, 4 8s. That is 32. Plus 2 9s. That's 18. All right, we add that to our original, to our tens column. So plus 2410. That's 2,546, and that is correct. And that is, the fast way to do it on a standard calculator. If you don't have a graphing calculator, then that's gonna be the best way to do it. So 2,546 4, 6. That was 136 added to that. That's our total. We're going to divide that number by 32 to get our mean. Divided by 32. That's going to be 79.56. And I believe that's where we want to stop. So let's just say 79.56. Let me double check that. Yeah. So look at how close the mean, the median, and the mode are within that set of points, within all of that data. Remember that we talked about the fact that if we had enough data, the mode, the median, and the mean would be the same number. So she could probably take scores of the same test from a second class that she gave the test to and add them in, and those three numbers would probably be, if not within a couple decimal points from each other, the same. So let's see what we can do with all of this. I'm going to write this up here where it is easy to reference. Range is 41. Median is 81.5, and the mean is 79.56. All right, I'm going to erase all of this right here so we actually have room to do something. We don't need any of those calculations anymore anyway. And I think I'll just move all of this over so we have the most amount of room to do what we need to do. There we go. Well, we don't really need all of this stuff anyway. All right, so we're going to look at how to make a box and a whisker plot and how that kind of compares to a bell curve, which is what we did with the normal distribution, with what we did with that. So we are going to separate the scores into 4 equal groups, and that allows us to see how the scores are spread out. So we're going to graph them on something like a number line. So let's do this here. Actually, I'm going to go ahead and do it to save you some time and then come back to it. So here is how we would plot or divide that box and whisker plot. This is how we would get started. First, we would figure out our quartiles. And a quartile is going to be where you take the number of points and you divide it by 4. And this is going to give you 1/4 of the scores in numeric order from lowest to highest per quartile. So we see in the first quartile that we go from the minimum of 55, which is the lowest. So we go from 55, so this is 1, 2, 3, 4, 5, 6, 7, 8. So 55 through that last 69 here, that is going to be your first quartile. So this is your first quartile right there. So then the next group of 8 is 1, 2, 3, 4, 5, 6, 7, 8. So this is the section for your second quartile. I'm just going to mark it that way. And then the next quartile, 1, 2, 3, 4, 5, 6, 7, 8 is here. And then the last quartile is all of the ones in the 90s. 1, 2, 3, 4, 5, 6, 7, 8. So if you notice, your quartile for the in between the second and the third is the same as your median. And what we do to do that is we go to that, just like we did for the median, we found that number, those two numbers in the middle, and we added them together and divided them by 2. And that gave us equidistant between the two quartiles. Well, that's exactly what we did to find the median. So the median automatically becomes the line separating the second and third quartile. So you should have 16 points on this side and 16 points on this side. Then you divide those points and you have a quartile of 8 here and a quartile of 8 here. And the way we get to that number that we go by is we take the last number in the first quartile and the first number in the second quartile. So it'd be 69, just like we did for the median, plus 71. That'd be this last number and this first number. Add them together, divide it by 2, and we find that that is 70. So that is where our quartile 1 ends, is on 70. And then for the end of the third quartile, we do the same thing. We get this last number, which is 88, plus the first number of the next quartile, which is 90. Add them together, divide it by 2, and 89 becomes the line for our third quartile. That's where we would indicate that at. And that's what we did. That's how we found those quartiles. So that is the start of creating that box and whisker plot. So now I'm going to show you how to finish that. So this is what your finished box and whisker plot should look like. You're going to keep the box for the second and third quartile. And then from your minimum, you're going to draw a line to the center of that first box. And then from the center of the second box, draw a line to your maximum. And this is the box that contains the central data. And then this records your outlying data, the 2 whiskers. All right, so why don't we try to do one of our own? I'm going to give you the data, and I am going to give you the quartile, the median. I'm not going to give you like the raw data to have to start from scratch, but I'll give you what you need in order to do a box and whisker plot. And let's just jump in and see if we can do one from that information. So here's our problem. Here's the data that we're given, and it's already sorted for us. All we need to do is come up with the sum of all of these numbers so that we can find the average. That's our first step. This is all that our problem is asking us for. It wants the mean, it wants the standard deviation, the minimum, quartile 1, the median, quartile 3, and the max. And all of that information is going to give us what we need to draw a box and whisker plot. So first let's find the mean. That's going to be the easiest. Well, the minimum is going to be the easiest to find, minimum and max. The minimum is 16. The max is 120. So those are the easiest to find. So now finding the mean is not going to be very difficult either. It's just the average. So we have 120, we have 50, we have 40, we have 33 plus 35. That's going to be 68. Then we have 22 plus 28. That's going to be 50. And then we have 16. So that's going to be 8 plus 6. That's 14. Carry 1. That's 8. That's 12. It's 18, 19, 24, carry a 2. This could be 344 divided by 1, 2, 3, 4, 5, 6, 7, 8. 344 divided by 8. That's going to give us our mean. $43 is our mean. All right, so that part was not too difficult. So now we're going to find our standard deviation. In order to find the standard deviation, remember we have got to find our variance. And first, in order to find our variance, we have to find all of the deviations, which means we need to plot each of these individual points. So we'll do that next. All right, so as we're going from step to step, it'd probably be a good idea for you guys to pause and then figure it for yourself, and then come back and look at the answer. So if you haven't done that, maybe pause, and see how we got to this next step and check your answer as we go. That might be a good idea. So for the first thing we did to find the mean was we added everything up, we divided it by the number, we got 43, right? So that set our mean on our number line. And then for each one of the data points, I just put a little mark here for them. It's not exactly what it would be on the number line, but it's enough to recognize their location. And then I just did some mathematics. I said 40 minus 43 is negative 3. 35 minus 43 is negative 8. 33 minus 43 is negative 10, and so forth and so on to get the distance from each point to the mean, which is the deviation. Then I took that deviation and I squared it, each one of them, and added it to all the other deviations. And because we had 8 numbers, then you divide that by 8. So once I squared it, I added it all up, divided it by 8, and the variance is 943.25. The standard deviation is the square root of that, and that was 30.71. So now I have my standard deviation. 30.71, and the standard deviation will allow me to do my bell curve and know where 68% of my points are, 95% of my points are going to be, and where 99% of my points be, and which ones are the outliers. So now we need to make our box and whisker plot. We're going to make our box and whisker plot by finding the quartile, and if we have 8 scores, then 8, the number of scores divided by 4, means that each quartile is going to have 2 points in it, and that's it. So I can already see my first quartile is going to be 16 and 22. My next quartile is going to be 28 to 33. My next quartile is 35 to 40, and my final quartile is 50 to 120. Because each one of these is going to be 2 numbers of the quartile. So that's going to help me a lot when I need to do my box and whisker plot, which I'm going to do right now. So go ahead and, using the data that you've been given, make that box and whisker plot. Press pause, make your box and whisker plot, and then come back and see what I have versus what you have. So looking at our box and whisker plot, it was really easy to find the median because all we had to do was count 1, 2, 3, 4, 1, 2, 3, 4, and the number between 33 and 35, which was 34, became our median. Now our first quartile, we went between 22 and 28. We said 22 plus 28, which is 50, divided by 2 is going to be 25. So that was our Q1. And for our Q3, we did the same thing. Our numbers were 40 and 50, and halfway between, well, if we add them together, that's 90, but it's technically halfway between, so it'd be 45. So 45 is our Q3. Now, our minimum was 16, and our max was 120. So this is what you should have ended up with for your box and whisker plot. Q1 of 25, median of 34, and a Q2 of 45. Or Q3, sorry, not a Q2. It's a Q3. And then you had your mins and your max, which was your the numbers you would use to find your range, if that was what we were asking for. So it would have been 120 minus 16 to find a range. Now, the data point 120 is what we call an outlier, and because it's an outlier, the relative importance of 120 is kind of questionable. You know, an outlier is a data point which lies well outside the range of the majority of the data points. And we can't disregard the data point when we do the calculations, but we can modify the box and whisker plot by not letting either whisker be more than 1.5 times the combined lengths of these 2 boxes. So since the combined lengths of both of these boxes, you just have to say the Q3 minus the Q1, that is going to be 20. So 1.5 times 20 would be 30, right? 20 times 1.5 would equal 30. So we would add 30 to our Q3, and that would be 75. And so that's where we would technically want to stop the whisker plot. But then we would put like an asterisk over here over our maximum amount. So what we would do to modify that, we would find 75 here. And I'm just going to get rid of that line and do a brand new one. So we know that if I have about 4 boxes here, 1.5 more, let's say that's right about, it's going to be right about yay, I think. So we'll put our little point here and we'll put 75 there, but then we'll put a little asterisk here to show that this is actually a data point. It's our maximum data point, but it's a major outlier. Like it falls well outside of the range of all of these other values. So you want to account for that. You want to keep the data in there to show it on a box and whisker plot. You might not use it for the sake of a focused study, but you would definitely record it as, you wouldn't want to just completely delete any data that you've gotten, because if you delete, that's kind of like falsifying the records. You don't want to do that, but you can drop it from your core stats, right? You still have that record of it. It's there, but it's not going to affect the direction that you go as a result of the study, because it's extra. It's an outlier. It's an exception to the rule, so to speak. So we call this distance that we say is no more than 1.5 times the length of both boxes. We call that, this is going to be your interquartile range. If I can spell it right. Interquartile range is what that is called. So we place that asterisk here, we put the point there, and voila, we have a new box and whisker plot. And that's all we have for lesson 61 finally, and we will be in lesson 62 next, and I will see you there.